Hello, I'm Knutsen, and I'd like to speak to you about genetically modified or transgenic salmon and their potential harm to our ecosystem. Transgenic salmon production is currently under evaluation in Canada and the United States, with an expected decision being made soon. As of 2012, the FDA has noted they do not find transgenic salmon pose a significant environmental impact for humans. Salmon has become a pretty hot commodity. In recent years, science has shown that omega-3 benefits heart health, regulates cholesterol, and affects learning and behavior in children. One of the better, more natural ways to get omega-3 is through the consumption of fish. Salmon, after sardines, have the highest level of omega-3. Given the increased demand for salmon, humans, of course, have turned to technology to speed up nature. Researchers isolated the promoter for the antifreeze gene from the ocean pout eel and installed it onto the growth hormone gene of salmon in order to encourage faster growth. The gene is then injected into salmon eggs. According to a review by researchers Robert Devlin, Frederick Sundstrom, and Rosalind Legat, transgenic salmon growth rate is 6 times that of wild salmon. This means bigger fish, available sooner, so more fish on the market. Of concern is the possible escape of potentially invasive species which would affect both the salmon as well as the ecosystem. The review notes that to study how transgenic fish would behave and affect their wild counterparts, researchers developed large contained labs. To make them more realistic, rocks, logs, natural food, plant life, and sometimes predators were added. Influences such as light, water type, and temperature were also manipulated to simulate natural occurrences. Salmon are migratory fish, however, so determining how transgenic salmon will behave in the wild is near impossible because of the limited data and because all scenarios cannot be studied in controlled environments. Development in fish is dependent upon size, so transgenic salmon reach sexual maturity in 2 years rather than 3 to 4 of wild salmon. The growth hormone also affects when salmon will hatch. Researchers observed transgenic coho salmon emerge from their eggs sooner than wild coho. This is beneficial in a low predator area where it is easier to get more food which does not have to be shared with the wild salmon. However, in high predation areas, the transgenic fry shouldered the burden of being prey alone. Due to the need for more food, transgenic salmon were observed with increasing time in feeding areas despite the presence of predators. The review reports it has been found that the base genes of salmon can change the trans gene and the growth hormone effects. The changes are not entirely known, but one effect may be that in nature, rapid growth is not optimal for survival, for the fish's genetics will change by increasing the slow growth gene. In wild salmon, growth would decrease and reduce their fitness for survival. This scenario has the possibility of edging out wild fish altogether. In conclusion, scientists, researchers, producers, and the FDA do not know what the eventual effect a transgenic migratory species will have on their wild counterparts or the ecosystem. With the genetic modifications, it is also impossible to say how crossmating will affect future generations of salmon. While producers purport they will be able to contain their production, history, such as with farmed salmon, has shown us that these claims are not always easy to maintain. If there is an escape, it would be impossible to remove the fish from a natural habitat like our oceans. I hope these findings frighten you as much as they do me. As an Alaskan resident and lover of salmon, I do not wish to have what nature already made perfect endangered.